Dear students, in the continuation of first lecture in which we discussed about what we mean about analog circuit, and in the last of lecture we concluded that in next lecture we should discuss about semiconductor devices. So in this lecture I am going to start from semiconductor material. So what is semiconductor? So here two words we can see, semi and conductor. So firstly we should discuss about what do you mean by conductor. Here conductor means we are going to deal with conduction of electricity. So we are going to deal with materials which can conduct electricity, or here conductor means which can conduct electricity. A material can conduct heat and material can conduct any other energy, but here we are going to deal with a material which can conduct electricity. On the basis of this, most of the material can be divided into three parts. The first one, conductor; second one, semiconductor; and the third one is insulator. As it deals with conduction of electricity, so conduction of electricity means flow of charge particles. Flow of charge particles means flow of electrons, as we know very well. So now the point of view of discussion is flow of electron in a material. So conductor is a material through which flow of electron is very easy, or flow of charge particle is very easy, or flow of current is very easy. So conductor is a material through which flow of electron or flow of charge particle or flow of current is very easy. Insulator is a material through which flow of electron is not possible or very difficult. Semiconductor is a material through which it is possible to flow of charge particle, and it is also not possible to flow of charge particle. It depends on conditions, situations. So it's signify that conductor can flow electron easily. That means it has large number of free electrons. And insulator, which cannot conduct electricity or which cannot conduct charge particles, it has no free electrons. It has no free electrons. Conductor has large number of free electrons and insulator has no free electron. But this semiconductor material can have free electron and also cannot have free electron. It depends on situation. So it has free electrons. That means in this type of material, its outermost electrons are not bonded. Outermost electrons are not bonded, means not stabilized, means free. In this type of material, material means molecule, means combination of atoms. That means this is combination of atoms where electron of atoms, outermost electrons or atom, are not stabilized by making bonds. And in insulator, no free electron means there is it's all outermost electrons are bonded. That means a strong bond. Bonded and strong bond. That means it cannot be broken. And generally, these are ionic bonds. Here, in conductor, these are metallic bonds. So, due to these situations, it will always provide free electrons, and it will show conduction of charged particles or conduction of free electron or conduction of current in every situation. And on the other hand, insulator, which has no free electron and there is no possibility of free electron, will not conduct electricity or current in any situation. Now the most important part is to come about semiconductor. In semiconductor material, different atoms are bonded by covalent bond. Atoms are bonded by covalent bond. For example, we can see about silicon, which has outer 4 electrons in its outermost shell. So these 4 electrons will be stabilized when this particular silicon atom has made bonds with 4 other silicon atoms. So we can say all electrons or outermost electron of these silicon atoms are stabilized by making bonds with 4 other silicon atoms, and these are covalent bonds. These are weak bonds actually, because these bonds are on the basis of sharing, whereas in insulator, bonds are ionic bonds, and these are give and take. One atom gives its electron to other atoms. So these are strong bond. But in the semiconductor, bonds are covalent bond, means there is sharing of electrons. So these bonds are weak. Although at due to making of bonds between atoms, these are stabilized, but these are stabilized by weaker bonds. If some external energies are applied on these bonds, bond will be broken easily. For example, suppose we apply temperature on this bond. We heat this molecule. We heat this molecule by applying some temperature, and then bond can be easily broken and electron can become free and vacancy can be created. This free electron will now available for flow of charge particle or flow of current. So we can see in the presence of some energy which can break bond, this semiconductor material can have free electron, and in absence of any external energy, this semiconductor material cannot have any free electron. So in absence of any external energy, or we can say very low temperature, we can say at 0 degree Kelvin temperature, it will behave like insulator because there will be no free electron. But in presence of some room temperature, or we can say temperature around 20 more than 27 degrees centigrade, bonds of some bonds of silicon molecule can be broken and some free electron can be available for the conduction of electricity. That's why this type of material is called semiconductor material, because its conductivity can be like conductor or can be like semiconductor. Here conductivity means conductivity, conduction plus ability. Conductivity, conduction, conductivity, conductivity means conduction plus ability, means ability to conduct. Ability to conduct. What conduct? Ability to conduct electricity. So a material which can have free electron easily, then it can conduct electricity easily. The material which cannot have free electron, it cannot conduct electricity easily, and it will be called insulator. But the material whose conductivity can be varied by applying some external energy like temperature are generally semiconductor material. So semiconductor material can be used as a sensor. That's why these are very useful in electronics. And at the time when so many devices were developed on the basis of semiconductor material, a branch of electronics came into the picture. So this is most important part of electronics and communication engineering branch, that is semiconductor material, and it is due to its variable conductivity on the basis of external energy. So the devices which are made by semiconductor materials are the part of electronics and communication engineering, and in the subject analog circuit we will deal with devices made by semiconductor material. This was all about, in this lecture, this was all about the conduction property of semiconductor material. In the next lecture we will deal with type of semiconductor material, and we'll discuss about p-n junction, and then after we'll discuss about devices based on p-n junction, diode, and then we can proceed for different devices in analog circuit. Thank you for this lecture.